Hello, my name is Ethan Scott Walden, and this is my video for the fluid simulation assignment. What I mainly did here was that I made the particles more reactive to the edges of the pan, and I also implemented a tilt force Y along to be used alongside the tilt force X and tilt force C. Let me demonstrate right now how this is going to work out. All right. So as you can see, they're bouncing off a little bit more when they hit the edges of the pan than they did before. I also want you to notice, yeah, you see how they're kind of flying up a little bit when you in both directions too. Take a look at that. So yeah, there's the splashing. It's caused by the tilt force Y. All right, now on to my code. Okay, this was an accident. Doesn't do anything. Um, all right. Uh, I just made a few changes to this, like how the pan reacted to controls. I'm pretty sure this was a math max and it was supposed to be a math min, and this was a math min and it was supposed to be a math max. So I just went and changed that, and it ended up looking a lot smoother as far as like controlling the pan goes. Okay. Also, we were having this little bug where the water particles were kind of like clipping like inside of the bottom of the cake pan. So to fix that, I disabled the depth testing while drawing the bottom of the cake pan. Yep, sorry. Yeah, I disabled the depth testing while drawing the bottom of the cake pan, and I made it so I had this like little Y offset, and this just made it so that it always appeared behind the water particles and everything else. Yeah. Okay, so this is kind of where the magic happens for, causing the splashing. Now these two variables are just the absolute value of the tilt force X and tilt force C, and they're being used down here in this equation for the tilt force Y. This is really where it happens. This is a little bit complicated, but I'll do my best to explain what's going on here. So there's two components here. There's the tilt force Y caused by the absolute value of the tilt force C, and that's added to the component caused by the absolute value of the tilt force X. These are, as you can see, only applied if tilt force Z and tilt force X are greater than 0.01. This is because, like, as you can see, the force that I'm applying is actually related to the inverse of the tilt force X and tilt force Z's absolute values. So actually, as the force decreases, the force that goes upward actually increases. This is kind of what allows the little water particles to semi-realistically pop up whenever you tilt it in one direction and then stop tilting it in that direction. You were seeing how the little water particles were like jumping up a little bit, and that's why. It actually is kind of always present, and it becomes a lot more present when you stop holding a direction. And then it pops up a little bit, and then it goes away because the tilt force really dissipates and it just falls down to the ground because of gravity. And of course, we apply this to the velocity in the y direction. I commented this line out because it made things a lot harder for us. I also commented out this outer if statement, just because it wasn't necessary. So the purpose of this if statement is to make sure that particles, if they go under the boundary that was set, as in boundary y, we just reset the position to be the cake pan position y. Also, did enhance the effects of the Um, I did enhance the effects of how the particles react when they hit the boundary of the pan, just to make it a little bit, you know. I remember that you were talking about like making it kind of more like a super ball, so I just made it more reactive. And that's it. Thank you. Oh, one more thing. I nearly forgot to highlight these parts. I did make a couple of changes to the gravity, damping, and propulsion strength fields inside of the particle class. I'm not sure these are actually necessary for the requirements. Maybe the gravity one may make it a little bit more easier to see how it's bouncing up. But besides that, not super necessary. Just wanted to bring up the fact that I changed it. Forgot to mention it earlier. Didn't highlight it initially in the original video, but now I did.